The National Electrical Code, or NEC, does not explicitly define industrial facilities as used in the specific context cited. However, the NEC does provide a definition for industrial establishment within Article 100. This definition, introduced in the 2002 NEC, clarifies what constitutes an industrial establishment. An industrial establishment is defined as a building or a group of buildings where products are manufactured or assembled. This definition is directly linked to the concept of an industrial occupancy. The term industrial, when used elsewhere throughout the NEC, is not specifically defined. In these instances, the common, everyday meaning of the word industrial should be applied. For example, the NEC does define industrial machinery. Industrial machinery refers to all machines and equipment used in a manufacturing, mining, or processing operation where the work is repetitive and consists of a series of operations. This definition helps to clarify the scope of industrial in the context of machinery. It is important to note that the restrictions of equal or greater than 2500 kV industrial/manufacturing load and 150 volts line to ground do not apply to all references to the term industrial elsewhere in the code. These restrictions are specific to certain applications and should not be generalized to all instances where the term industrial is used. To further clarify, let's consider some examples of how the term industrial might be used in the NEC. Firstly, consider Article 210.3, which deals with branch circuits. This section specifies requirements for branch circuits serving various types of loads. When the NEC refers to industrial facilities in this context, it is implying a setting where qualified personnel are responsible for maintenance and supervision of the electrical installations. This ensures a higher level of safety and reliability. Secondly, Article 210.9 addresses circuits derived from auto transformers. Again, when the section refers to industrial facilities, it assumes a level of oversight by qualified individuals. Thirdly, Article 215.11 pertains to feeder circuits in industrial establishments. This section likely focuses on ensuring that these feeders are adequately sized and protected, given the potentially heavy loads associated with industrial operations. Fourthly, consider Article 318.3 and 318.6, which cover cable trays. The reference to industrial facilities in these articles suggests that cable trays in such environments may be subject to different installation requirements due to factors such as the presence of corrosive substances or high ambient temperatures. Fifthly, Article 340.4 deals with underground feeder and branch circuit cable, or UF cable. In the context of industrial facilities, the use of UF cable may be subject to specific limitations or requirements. Sixthly, Article 364.8 relates to bare conductor risers. The NEC reference to industrial facilities in this article implies that the installation and maintenance of these risers must be carefully managed by qualified personnel. Seventhly, Article 370.50 covers outlet boxes and fittings. In industrial settings, these components may need to be of a more robust design to withstand the rigors of the environment. Eighthly, Articles 501.4 and 501.11 address hazardous locations, specifically Class 1, Division 1 and Division 2 locations. These articles contain numerous references to industrial facilities where flammable gases or vapors may be present. The NEC requirements for these locations are particularly stringent to prevent explosions and fires. Ninthly, Article 502.4 pertains to Class 2, Division 1 and Division 2 hazardous locations where combustible dust may be present. Similar to Class 1 locations, the NEC imposes strict requirements for electrical equipment in these areas to minimize the risk of dust explosions. Understanding these specific examples helps to illustrate how the term industrial is applied in various sections of the NEC. It is crucial to consult the specific article in question to determine the exact requirements for industrial facilities. To summarize, the NEC defines industrial establishment in Article 100 as a building or group of buildings where products are manufactured or assembled. The term industrial, as used elsewhere in the NEC, takes on its common meaning, unless specifically defined within that article, such as in the case of industrial machinery. The restrictions of equal to or greater than 2500 kV industrial/manufacturing load and 150 volts line to ground do not apply to all references to the term industrial in the code. Always refer to the specific article in the NEC for the applicable requirements for industrial facilities. For example, let's explore the implications of these definitions and applications with a more detailed look at specific NEC articles. Considering Article 210, which covers branch circuits, the NEC uses the term industrial facility to delineate areas where stricter electrical maintenance and supervision are expected. This higher standard acknowledges the more complex and potentially hazardous electrical systems often found in industrial settings. This emphasis on qualified personnel ensures that electrical work is performed safely and correctly, minimizing the risk of accidents and equipment failures. For instance, in an industrial facility with numerous machines operating simultaneously, branch circuits must be designed to handle the combined load. Qualified personnel would be responsible for calculating these loads accurately, selecting appropriate wire sizes, and installing overcurrent protection devices such as circuit breakers or fuses to prevent overloads and short circuits. Furthermore, the presence of qualified personnel allows for regular inspections and maintenance of the electrical system. This includes checking for loose connections, damaged wiring, and other potential hazards. By proactively addressing these issues, the risk of electrical problems can be significantly reduced, leading to improved safety and reliability. Now, let's examine Article 215, which deals with feeders. Feeders are the conductors that carry electrical power from the service equipment to one or more branch circuit overcurrent devices. In industrial establishments, feeders often supply power to large machines, lighting systems, and other significant loads. Therefore, the proper design and installation of feeders are critical to ensuring a reliable and safe electrical system. Article 215.2 addresses the minimum size and rating of feeder conductors. Feeders must be sized to carry the calculated load, taking into account factors such as the demand factor, which recognizes that not all loads will operate at their maximum capacity simultaneously. In industrial facilities, where loads may vary significantly depending on the production schedule, accurate load calculations are essential. In addition to sizing conductors, Article 215 also addresses the requirements for overcurrent protection. Feeders must be protected by circuit breakers or fuses that are sized to protect the conductors from overloads and short circuits. The overcurrent protection devices must be coordinated with the overcurrent protection devices on the branch circuits to ensure that a fault on a branch circuit will not trip the feeder breaker, causing a widespread outage. Furthermore, let's delve into Article 318 concerning cable trays. Cable trays are rigid structures used to support insulated conductors and cables. They are commonly used in industrial facilities to route and manage large quantities of wiring. Article 318 provides requirements for the installation and support of cable trays, as well as the types of cables that are permitted to be installed in cable trays. The NEC reference to industrial facilities in Article 318 highlights the importance of proper cable management in these environments. In industrial settings, cable trays are often subjected to harsh conditions such as exposure to corrosive substances, high temperatures, and mechanical stress. Therefore, it is essential to select cable trays and cables that are suitable for the specific environment. For example, in a chemical plant, cable trays and cables may need to be made of corrosion-resistant materials such as stainless steel or PVC. In a steel mill, cable trays and cables may need to be able to withstand high temperatures. Now consider Articles 501 and 502, which address hazardous locations. Hazardous locations are areas where flammable gases, vapors, or combustible dusts are present, creating a risk of fire or explosion. Industrial facilities are often classified as hazardous locations due to the presence of these materials. Articles 501 and 502 contain detailed requirements for electrical equipment installed in hazardous locations. These requirements are designed to prevent ignition of flammable materials and to minimize the risk of explosions. For example, electrical equipment in hazardous locations must be explosion-proof or intrinsically safe. Explosion-proof equipment is designed to contain any explosion that may occur within the equipment, preventing it from igniting the surrounding atmosphere. Intrinsically safe equipment is designed to operate at such low voltage and current levels that it cannot produce a spark capable of igniting flammable materials. In addition to explosion-proof and intrinsically safe equipment, Articles 501 and 502 also address requirements for wiring methods, sealing, and bonding. These requirements are designed to prevent the spread of flammable materials and to ensure that electrical equipment is properly grounded. Furthermore, it's critical to understand the nuances between different types of industrial settings. A large manufacturing plant producing automotive parts will have vastly different electrical needs and safety considerations compared to a small-scale food processing facility. The automotive plant might have heavy machinery demanding high voltage and current, requiring robust and well-maintained electrical distribution systems. The food processing facility, on the other hand, might prioritize hygiene and sanitation, necessitating special wiring methods and equipment to prevent contamination. These distinctions underscore the importance of not only adhering to the NEC but also conducting thorough site-specific risk assessments to identify potential hazards and tailor electrical installations accordingly. Another important consideration is the increasing integration of automation and technology in industrial facilities. Programmable logic controllers, or PLCs, robotic systems, and advanced sensor networks are becoming increasingly common. These technologies rely heavily on sophisticated electrical and electronic systems, requiring qualified personnel with expertise in both electrical and control systems. Therefore, ongoing training and professional development are essential for electrical workers in industrial settings to stay abreast of the latest technologies and best practices. Moreover, the NEC is not a static document. It is revised and updated every 3 years to reflect changes in technology, industry practices, and safety standards. Electrical professionals working in industrial facilities must stay informed of these updates to ensure that their installations comply with the latest requirements. In summary, navigating the NEC requirements for industrial facilities demands a comprehensive understanding of the code, a strong foundation in electrical principles, and a commitment to ongoing learning. By adhering to the NEC and implementing sound engineering practices, electrical professionals can help ensure the safety, reliability, and efficiency of electrical systems in industrial environments. Let's dive deeper into the application of the term industrial within the context of specific NEC articles to provide further clarity. Consider Article 430, which covers motors, motor circuits, and controllers. Motors are ubiquitous in industrial settings, powering everything from pumps and fans to conveyors and machine tools. Therefore, Article 430 is particularly relevant to industrial facilities. When the NEC refers to industrial machinery in Article 430, it is generally referring to machines used in manufacturing, mining, or processing operations where the work is repetitive and consists of a series of operations. This definition helps to distinguish between industrial machinery and other types of motor-driven equipment, such as household appliances. Article 430 provides detailed requirements for the sizing of motor conductors, overcurrent protection, and control circuits. These requirements are designed to protect motors from overloads, short circuits, and other electrical faults. In industrial facilities, motors are often subjected to demanding operating conditions, such as frequent starts and stops, high ambient temperatures, and exposure to contaminants. Therefore, it is essential to select motors and control equipment that are suitable for the specific application. For example, motors used in hazardous locations must be explosion-proof or intrinsically safe, as previously discussed. In addition to Article 430, other NEC articles also contain provisions that are specifically applicable to industrial facilities. For example, Article 480 covers storage batteries. Storage batteries are often used in industrial facilities to provide backup power for critical equipment, such as emergency lighting and fire alarm systems. Article 480 provides requirements for the installation, ventilation, and charging of storage batteries. These requirements are designed to prevent explosions and to ensure that batteries are properly maintained. Another relevant article is Article 670, which covers industrial machinery. Article 670 provides requirements for the disconnecting means over current protection and grounding of industrial machinery. These requirements are designed to protect workers from electrical hazards and to ensure that machinery is properly grounded. Furthermore, Article 680 covers swimming pools, fountains, and similar installations. While this article may seem irrelevant to industrial facilities, it can be applicable in certain situations. For example, some industrial facilities may have swimming pools or fountains for recreational purposes or as part of a cooling system. Article 680 provides requirements for the electrical safety of these installations. This includes requirements for ground fault circuit interrupters, or GFCIs, bonding, and underwater lighting. In addition to these specific articles, the NEC also contains general requirements that are applicable to all electrical installations, including those in industrial facilities. For example, Article 110 covers general requirements for electrical installations. This article provides requirements for workmanship, wiring methods, and equipment markings. Article 250 covers grounding and bonding. Proper grounding and bonding are essential for electrical safety and to prevent electric shock hazards. Article 300 covers wiring methods and materials. This article provides requirements for the types of wiring methods that are permitted in different locations. In conclusion, understanding the NEC requirements for industrial facilities requires a comprehensive knowledge of the code and a careful consideration of the specific application. It is essential to consult the specific article in question to determine the exact requirements. By adhering to the NEC and implementing sound engineering practices, electrical professionals can help ensure the safety, reliability, and efficiency of electrical systems in industrial environments. The role of qualified personnel cannot be overstated in ensuring the safe and effective operation of electrical systems in industrial facilities. These individuals possess the necessary training, experience, and knowledge to design, install, maintain, and troubleshoot complex electrical systems. The NEC recognizes the importance of qualified personnel by including provisions that require or recommend their involvement in certain aspects of electrical work. For example, the NEC may require that certain types of equipment be installed or maintained only by qualified personnel. This is particularly common in hazardous locations where the risk of fire or explosion is high. Qualified personnel are also essential for conducting regular inspections and maintenance of electrical systems. These inspections can help to identify potential hazards and to prevent equipment failures. Maintenance tasks such as tightening connections, replacing worn parts, and testing over current protection devices should be performed by qualified personnel to ensure that they are done correctly and safely. In addition to their technical skills, qualified personnel must also be knowledgeable about the NEC and other relevant codes and standards. This knowledge is essential for ensuring that electrical installations comply with all applicable requirements. Furthermore, qualified personnel must be able to communicate effectively with other members of the workforce. This includes explaining electrical concepts to non-electrical personnel and coordinating electrical work with other trades. To become qualified, individuals typically undergo formal training programs such as apprenticeships or vocational schools. These programs provide instruction in electrical theory, wiring methods, and safety practices. Upon completion of their training, individuals may be required to pass a licensing exam to demonstrate their competency. Continuing education is also essential for qualified personnel to stay abreast of the latest technologies and code changes. There are numerous resources available to help electrical professionals stay informed. These include industry publications, training courses, and professional organizations. By investing in their education and training, electrical professionals can ensure that they have the skills and knowledge necessary to perform their jobs safely and effectively. Now, consider the concept of suitability as it relates to electrical equipment and installations in industrial facilities. The NEC places a strong emphasis on the suitability of equipment for its intended use and environment. This means that electrical equipment must be designed, constructed, and installed in a manner that is appropriate for the specific conditions in which it will be used. Several factors must be considered when determining the suitability of electrical equipment. These include the ambient temperature, the presence of corrosive substances, the presence of flammable materials, and the mechanical stresses to which the equipment will be subjected. For example, electrical equipment installed in a hot environment must be designed to operate at high temperatures without overheating. Electrical equipment installed in a corrosive environment must be made of materials that are resistant to corrosion. Electrical equipment installed in a hazardous location must be explosion-proof or intrinsically safe. Electrical equipment installed in a location where it will be subjected to mechanical stress must be designed to withstand that stress. The NEC provides guidance on the selection of suitable electrical equipment in various articles. For example, Article 110.3 provides general requirements for the examination, identification, installation, and use of equipment. This article requires that the equipment be listed or labeled by a recognized testing laboratory to indicate that it has been tested and found to be suitable for its intended use. Article 300.3 provides requirements for the use of conductors of different systems in the same raceway, cable, or enclosure. This article requires that conductors of different systems be insulated for the maximum voltage of any conductor in the raceway, cable, or enclosure. Article 430 provides requirements for the selection of motor controllers. This article requires that motor controllers be suitable for the type of motor being controlled and the operating conditions. In addition to the NEC, other codes and standards may also provide guidance on the selection of suitable electrical equipment. For example, the National Electrical Manufacturers Association, or NEMA, publishes standards for electrical enclosures. These standards provide requirements for the construction and performance of electrical enclosures. The Underwriters Laboratories, or UL, publishes standards for a wide range of electrical equipment. These standards provide requirements for the safety and performance of electrical equipment. By carefully considering the factors that affect suitability and by selecting equipment that meets the applicable codes and standards, electrical professionals can help ensure the safety and reliability of electrical installations in industrial facilities. The NEC emphasis on using the common meaning of industrial when it's not specifically defined highlights the importance of context and reasonable interpretation. Electrical codes, while comprehensive, cannot cover every conceivable situation. Therefore, engineers and electricians must often rely on their professional judgment and understanding of the industry to make informed decisions. This flexibility allows the code to be applied effectively in a wide range of industrial settings, each with its unique characteristics and challenges. However, it also underscores the need for continuous learning and staying updated on industry best practices to ensure safe and compliant installations.